Welcome to the next in the series of lectures on the gas laws. You are going to need your pencil or pen and paper. You are going to need your calculator, and for this lesson you need your red, white, and blue periodic table as well as your mole map. Remember that your mole map is on the belly of your mole, but your mole map shows you the mole in the center, and it shows you how to convert from moles to particles using Avogadro's number, and shows you how to convert from moles to mass using periodic table, and it shows you how to convert from moles to volume using 22.4 liters. So just a recap, the mass is from the periodic table. Okay, and actually I want to do it this way. Mass is in, get a different color, there we go, grams per mole. Remember that if you want to go from moles to mass, you have to multiply, and to go from mass up to moles, you have to divide. Volume is 22.4 liters. To go from moles to volume, you have to multiply by 22.4. To go from volume back to moles, you have to divide by 22.4. And particles are Avogadro's number of 6.02 e to the 23. To go from moles of particles, you have to multiply by 6.02 E23, and to go from particles back to moles, you have to divide by 6.02 E23. So remember your mole map. If you don't have your mole map on you, you can't find it. Pause this video and write that down real quick and put that to the side. But you are going to be responsible for either knowing your mole map or having it on the belly of your mole. Remember that. Also, for the ideal gas law, we need to remind you of standards. Remember that there is a temperature standard and there is a pressure standard. Standard temperature is 0 degrees Celsius. That is the temperature at which water turns to ice. And remember, to convert from degrees Celsius to Kelvin, we add 273. That gives us our Kelvin. And it is also 273 Kelvin, which is a standard temperature. And to go from Kelvin back to degrees Celsius, we take away 273. And that is going to give us degrees Celsius. Remember that the unit for Celsius has a degree, whereas the unit for Kelvin does not. Now, but we're talking about the ideal gas law. And in the ideal gas law, generally, we only use Kelvin. We use Kelvin for our units in describing the temperature, and we use Kelvin for doing our calculations. However, if I specifically tell you that I want degrees Celsius, or I give you degrees Celsius as a possible unit that I want, then of course you then convert from Kelvin back to degrees Celsius. But other than that, we use Kelvin when we're talking about the ideal gas, because this is an ideal gas. This is like the perfect gas. Okay? And finally, one extra little reminder. Remember your standard pressures. And remember that your standard pressure can be in atmospheres, in which case it's 1 atmosphere. It can be in kilopascals, where it is 101.3 kilopascals. It can be in torr, when it's 760 torr. It can be in millimeters of mercury, where it is 760 millimeters of mercury. And it can be, for our purposes, in pounds per square inch, when it's 14.7 psi or pounds per square inch. Again, make sure that you know these. Okay? All right, and again, write them down if you don't have them with you. Otherwise, you should have them somewhere beside you. Okay, so these are things that you need to know. So make sure you got your pencil, you should have your paper, you should have your calculator, your red, white, blue periodic table, your mole map. You should have memorized the standards of temperature and standards of pressure as we go through the ideal gas law. This is the ideal gas law. In the ideal gas law, we look at a condition of the gas. We do not look at a condition as it changes from one condition to another. We're looking at the condition or a condition of gas at a particular pressure, a particular volume, at a particular temperature. Okay. The ideal gas law obeys Boyle's and Charles' law. If you remember, Boyle's law is that PV in condition 1 is equal to PV in condition 2. That's Boyle's law. Charles' law says the volume in condition 1 with the temperature in condition 1 is equal to a volume in condition 2 over temperature in condition 2. So we have taken both Boyle's law and Charles' law, and we have created the ideal gas law because the gas obeys those two laws perfectly. Okay? So what's new? Well, we are now adding moles to the formula, and the lowercase n is our symbol for the moles of the gas. And we're using R. R is a molar gas constant, and the molar gas constant goes with the pressure. So somewhere put down that the molar gas constant correlates or corresponds with the pressure that you're using. So if we're using atmosphere, then it is 0.0821. If we're using kilopascals, it is 8.314. If we are using torr, it is 62.4. And if we're using pounds per square inch, it is 1.21 liters. Now remember that torr and millimeters of mercury are pretty much the same, so they're both going to use 62.4. So just remember that if I give you millimeters of mercury, that torr and millimeters of mercury are both going to use this 62.4. Okay? Also, for just take a second, notice a couple of things that the R or the molar gas constant only uses the liter. So that's going to give you a clue as to what the unit for volume has to be for the ideal gas law. But let's look at each part of the ideal gas law so that we can get an idea of how they all work together. So we know the formula for ideal gas law is PV is equal to nRT. Pressure can be any pressure unit that we discussed. So it can be atmospheres, it can be kilopascals, it can be torr, millimeters of mercury, it can be PSI. So this can be any pressure unit. But the big ones I want you to look at is that volume has to be in liters. The N or the moles, R has to match your pressure unit. And look at here, temperature has to be in Kelvin. So your big ones are liters, has to be for volumes. Kelvin has to be for temperature. Pressure is going to be any of those that we're used to pressure being: atmosphere, kilopascals, torr, millimeters of mercury, PSI. Okay? But volume has to be in liters. So if I give you volume is in milliliters, you're going to have to convert it to liters. And if I give you your temperature in degrees Celsius, of course, you have to convert that in Kelvin. So how familiar are we with converting from liters to milliliters? Remember that if you have liters, 1 liter is equal to 1,000 milliliters. So if I want to go from liters to milliliters, I need to multiply by 1,000, and that will give me milliliters. If I want to go from milliliters to liters, I have to divide by 1,000, and that will give me liters. So make sure that you write that down somewhere. Keep that somewhere so that you can do your conversions as necessary. Okay? Okay. Big thing, of course, is we work in Kelvin. If we report the gas law in degrees Celsius, we convert from Kelvin. Otherwise, generally, we only use Kelvin for gas laws. Okay? Okay. Let's look at the first problem. What volume is needed to store 0.050 moles of helium gas at 202.6 kilopascals and 400 K? All right, let's break this up into all its little individual pieces. We know that ideal gas law is PV is equal to nRT. So that's good. And then we look at this. We know that we have N, which is our moles. We know that we have the pressure in P. And we know that we have the temperature, and they kindly gave it to you in Kelvin, so you don't have to worry about it. So what is actually missing? We don't know what the volume is, and we don't know what R is. Well, R is going to be given to you, so we're not going to worry about that too much. But the rest of them is a plug and chug. You've got to plug that in. Now, do I need to do something about this helium gas right here? Absolutely not. Because you have your moles. I'd only need to do something about helium gas if they gave it to me in, like, say, particles, or they gave it to me in liters, or they gave it to me in its mass in order to use my mole map and get back to the moles. So I don't need to worry about that. Okay? All right, so let's look at all the parameters that we have then. We have our pressure, which is 202.6 kilopascals. We have our temperature, which is 400 K and doesn't need to be converted because it's already in Kelvin. Our moles is 0.05 moles. And we have our R value, since this is dealing with kilopascals. This is the R value for kilopascals. Okay? So we're going to take all this and plug this into our formula. Plugging everybody in where they go. Here is our pressure. This is the volume we don't know. This is our moles. This is our R value. And this is our temperature. So everybody's plugged in. Because I want my volume, I'm going to need to get rid of the 202.6 kilopascals, solving for V. And I think this flips it around. It gives us this setup. So now V is equal to everything we said, our moles, our R value, our temperature, and this is our pressure. So clear your calculator. Open parentheses, 0.05 times 8.314 times 400, because these are all to be multiplied by each other this time, divided by 202.6. Push the equal sign. And you should have gotten 0.821. Since I'm talking about volume, and volume has to be in liters, then my unit is going to be in liters. Pause the video if you need to, or rewind it if you need to go back and do the problem. Make sure you understand it, or write questions if you have those. Hopefully we'll get them answered. Okay? Let's look at another one. What pressure in kilopascals will be exerted by 20.16 grams of hydrogen gas in a 7.5 liter cylinder at 20 degrees Celsius? Well, Here is our volume. Here is our temperature. That is all we have. Well, we know that ideal gas's PV is equal to nRT. So we've got to do something about our temperature, which is at 20 degrees Celsius. We're going to have to add 273 to give us 293 K. And we've got to do something about the fact that we have grams of hydrogen gas. Well, I can't use grams. I need to have moles. Well, if this is mole, remember you have mole, and if it's going to grams, we would multiply by the molar mass, grams per mole. But if I'm going from grams back to mole, I need to divide by the molar mass of grams per mole. That means I need the molar mass of hydrogen gas. Well, what's the formula for hydrogen gas? Is it going to be hydrogen or is it going to be hydrogen sub 2? If you chose the hydrogen sub 2, you are correct. So, look at your red, white, and blue periodic table. Find the molar mass of hydrogen, which is 1, and the molecule of hydrogen gas is H2. So this has a molar mass of 2 grams per mole. So I'm going to take my 2 grams per mole, and I'm going to take that and divide that into the number of grams that I have. So this is going to become 20.16 divided by the molar mass of hydrogen gas, which is 2. Using your calculator, 20.16 divided by 2 is going to give you 10.08 moles. And that is what you're going to put into the rest of your PV is equal to nRT. Okay. What else do I need to look at? Oh, I need to find the R value for kilopascals. And again, that's going to be given to you. So I now have my N that I need. I have my R that I need. I have my volume that I need. And I have my temperature, which is adjusted to 293 K that I need. I have everything I need to plug into the PV is equal to nRT. All right, so when I lay them all out, I have my volume of 7.5 liters, my temperature of 293 K, my R value for this is 8.314, and my mass, which was 20.16 grams, and I went ahead and found the number of moles of my mass of 20.16 grams. I divided it by 2 to get 10.08 moles, and so now I have my N. And now I can plug those into my equation. And in plugging those into my equation, here are all my parts of my equation. Here is the pressure, which I need to find. This is my volume. Here is my moles. Here's my R value. Here is my, put it up under here a little better. Here is my temperature in Kelvin. So in order to get my pressure together, I'm going to multiply my nRT, and I'm going to divide both of those by my V to get rid of that. And when I do that and set that up correctly, open your, clear your calculator. You're going to have an open parentheses, 10 times 8.314 times 293, which is my temperature, divided by my pressure, my volume of 7.2 liters. Push the equal sign, and you should get 3,274. And since I am talking about kilopascals, make sure you give me the unit of kilopascals. Okay, pause the video if you need to, rewind if you need to, or keep going. A 50-liter cylinder is filled with argon gas to a pressure of 10130.0 kilopascals at 30 degrees Celsius. How many moles of argon gas are in the cylinder? So what is it that I need to know? I do need to know that I have argon gas because I have to be able to do I really need to know that I have argon? Actually, I don't need to know that I have argon gas because I am calculating my moles. So the fact that I have argon gas is kind of what you call extraneous information. But I do know my volume. I do know my pressure. I do know my temperature. So all I really need to know for this is what is my R value. And R value will be given me so I can calculate the moles. So let's look at all the parts of this. My volume, is 50 liters. Temperature is 30, and I add 273, which we know to get 303K. There it is. Pressure is 10130.0 kilopascals. Don't get confused. I know it looks like the standard, but this pressure is not 101.3 kilopascals. So don't get confused. All right, that's a whole different one. All right. So my R value for this is 8.314. I'm going to take them all and plug them in to my equation. Here you have my pressure, you have my volume, you have to find moles because that's what's missing, you have my R, and you have my temperature. So I need to get this information away from my moles. So I'm going to divide them by both sides, which sets up my equation to look like this. Don't mean to give that answer away so quickly. Okay. So now I'm going to, this is my pressure times my volume divided by my number of mole, my R value, times my temperature. So clear your calculator. Open parentheses 10130.0 times 50, close parentheses, divided by, open parentheses again, 8.314 times 303, close parentheses, press the equal sign, and that is going to give us the number of moles, which should be 201.1 moles. And because I'm asking you for moles, make sure you give me the unit for moles. Okay? All right, let's try another one. Again, please make sure that you are pausing the video as you need to, or writing questions down as you need to see if they're answered, or just going back and rewinding the video and doing the problems with me. You don't need new problems. You need to know how to do these problems so that you can do any of the problems that we give you. All right? Okay. To what temperature does a 250 milliliter cylinder containing 0.40 grams of helium gas need to be cooled in order for the pressure to be 253.25 kilopascals? Don't get nervous because it's a word problem. We're going to break it up just like we did before. We already know what our formula is, right? Okay, so we have our volume is given. We have our pressure is given. We need to find our temperature. Okay. And of course the R value will be given to us. So what do we need to fix for this? Well, if you're paying attention, we don't have the N. the moles, but we do have 0.40 of helium gas. Once again, we have to look to our mole map, and we're going to and from. Remember, if we're talking about mass, well, if we're going from mole to mass, we multiply, right? If we're going from mass to mole, we divide. Well, we're going from mass to mole. So we're going to have to divide the grams per mole. So we need to know what the molar mass of helium gas is. Well, look at helium on your periodic table. First of all, what is the formula for helium? Is it He or is it He subscript 2? If you chose He, you are absolutely correct. So we know that the molar mass of helium is 4 grams per mole. So in order for me to calculate what my moles are going to be, I'm going to have to take the molar mass of helium with the number of grams that I have. So that's 0.40 grams divided by the molar mass, which is 4 grams per mole. And that is going to give me my moles. I also need to look at my volume. I have 250 milliliters of volume. I need my volume to be in liters. And remember, I told you to go from liters to milliliters. You multiply by 1,000. To go from milliliters to liters, we're going to divide that by 1,000. Okay? And this is milliliters per liter. So look at your calculator. We got 2 things we got to do to find our volume and to find our moles. So for our moles, we're going to take 0.40 and divide that by 4, and that is going to give us 0.1 moles. I think my 1 can look a little better than it does. And then for my volume, I'm going to take 250 and divide it by 1,000, and that is going to give me 0.25 liters. Okay, so now I know my moles and I know my liters. I've got my moles, I've got my liters, I've got my pressure. I'm going to be given my R value. I need to figure out what my temperature is. Okay, so we lay these all out so we can see them clearly. Volume is 250 milliliters. This needs to be changed. Mass is 0.4 grams. Pressure is 253.25 kilopascals. R is 8.314. I think this is quite incorrect. Finding the number moles. That's our 0.1. But I need to make sure. There we go. 250 milliliters. 0.25. So they just wrote it wrong. They forgot to put a point on that 0.25. So I don't need to go back and redo this lecture because I've done so much. So that should be 0.25. They just wrote it wrong. So here we have our pressure. You have the volume that we calculated. You have the moles. You have the R value. We do not have the T. So we need to figure out what T is. And in order to do that, we need to get rid of the moles times the R value, R constant. So T is left by itself. When we do that, we set up the equation. So you can clearly see that you have pressure times volume divided by number of moles times the R value to give us T. So clear your calculator. Okay. Open parentheses, 253.25 0.25 times 0.25, close parentheses, divided by, open parentheses, 0.1 times 8.314, close parentheses, and that is going to give us our temperature in Kelvin. And since they made a little error here with the 0.25, I'm going to go ahead and do that calculation to make sure that it matches what's on the screen. So open parentheses, 253.25 times 0.25, close parentheses, divided by, open parentheses, 0.10 times 8.314, close parentheses. I am getting 76.15 K. Okay, that's what I get. So let's see if they've got this right, if they made allowances for that 0.25 that they didn't have. 76.15 K. All right. If I wanted that, of course, to be changed into degrees Celsius, I would subtract 273, which would give me a negative 96.8 degrees Celsius. Okay, so not bad. The key has a couple of issues. Again, they need to make sure that that's 0.25. But we adjusted for that, and I'll make sure that gets fixed on the PowerPoint that you'll be able to go back over. You review PowerPoint and the PowerPoint, the lectures that you can go back over. So here is our answer to our problem. If you got that, you are doing so great, just so great. You should feel really, really good about yourself. If you got a little bit stuck, not quite sure, please make sure you write that down so you can address that with your instructor, okay? Or go back over the lecture to see if we fix that and you have a better understanding of that, okay? Okay, look at this problem. If there are 4 moles of a gas at a pressure of 5.6 atmospheres and a volume of 12 liters, what is your temperature going to be? All right, once more, we have our formula. We have our N. We have our pressure. We have our volume. We don't know what our temperature is. So our value will be given to you. So we pretty much have everything we need. So let's lay this out. If you see a little delay, it is because I have people calling me on the phone. All right, so let's look at everything that we have here. We're just looking for K. We know what R is. So here is your pressure, and here is our volume. Here are our moles, and here's the R value, and this is the temperature that we're trying to find. Again, we need to get rid of our R values, our N and R values, so we're going to divide both sides by your moles and your R value. God, I could write that a little bit better. Thank you, Lord. Okay. Cancel these out, so I'm left with the value of T. So when I lay that out correctly, I should, I guess you got to do this like right now. All right, so let's just lay this out. 5.6 times 12 divided by, in parentheses, 4 times 0.0821. Do you guys notice that you have a different R value right now? And the reason you have this is because we're dealing with atmospheres. We're not dealing with kilopascals. Okay, so when you do that, open your parentheses, 5.6 times 1, 2, close parentheses, divided by, open parentheses, 4 times 0.0821, close parentheses, and hit the equal sign, you come up with 204.6 Kelvin. And if I was going to convert that into degrees Celsius, I would, of course, subtract 273, which is going to give me a negative 68 degrees Celsius. Okay? Check it carefully. Make sure you understand that. Okay, look at this one. An unknown quantity of gas at a pressure of 1.2 atmospheres, a volume of 31 liters, has a temperature of 87 degrees Celsius. How many moles of gas are there? See if you can't do this one by yourself. And press play when you're ready to check. So, we know we have a pressure. We know we have a volume. We know we have a temperature. What we're missing are the R values, and we're missing our number of moles. Well, R values are going to be given us, so we're not going to worry about that. And on our values or factors that we do have, we are going to have to change that temperature because it's in degrees Celsius. So temperature is going to have to be changed from 87. We're going to have to add 273. And if we add 273 to 87, we get 360 K. So now we've got our temperature. All right. So if we lay out all of our things into a the way we laid them out, then we have our pressure and we have our volume, and that is going to be equal to our N we do not know, but we do know our R value, and we know what our temperature is. So we're going to divide both sides by our R value times our temperature. Okay, they're going to cancel out here. So N is then going to be equal to, open parentheses, 1.2 times 31 divided by, open parentheses, 0.821 times 360, close parentheses, press the equal sign, and our moles for this should be equal to 1.26, and we are asking for moles, so we get moles as our unit back. Okay? All right, if you're getting these correct, you're doing just fine. If you have questions, make sure that you're asking them. Look at this one. If 17 moles of gas has a temperature of 67 degrees Celsius and a volume of 88.89 liters, what is the pressure of the gas in kilopascals, and what is the pressure of the gas in atmospheres? All right, see if you can't calculate what it is in kilopascals. Then come back and check your answer, and I'll show you how you do it in atmospheres also. Okay? Okay, so I have my moles. I have my temperature. I have my volume. And I'm looking for my pressure. And R value would be given me. So what do I need to fix? Moles, temperature. I do need to fix my temperature. So my temperature is going to be 67 plus 273. And 67 plus 273 is equal to 340 K. So there is my K. All right. And like I said, R is going to be given me. So I should be able to plug all of these in to get my pressure. So when I do that, let me see how that's going to pan. So my setup looks decent. So I have to solve for P. Here's my V. This is equal to my N times my R times my T. So in order to get P, I'm going to need to divide both sides by V. Okay. So to do that, trying to find a faster and easier way to do that without doing all this writing, I divide this side by 88.89. and I divide this by 88.89. Okay, that cancels it here. So P is going to give me kilopascals. So open parentheses, 17 times 8.1314 times 340, which is T, divided by my volume, which is, make sure you close the parentheses, 88.89. So once again, that's open parentheses, 17 times 8.314 times 340, close parentheses, divided by 88.89. And that is going to give you your pressure in kilopascals, which should be 540 kilopascals. Okay? Now, I know that I have 540 kilopascals. I also need to know it in atmospheres. Well, I already know that 1 atmosphere is the same as 101.3 kilopascals, because that's my standard, right? Okay, so I can take my 540 kilopascals and I can multiply that by 1 atmosphere to every 101.3 kilopascals. Okay, so take your calculator, 540 divided by 101.3 kilopascals, and that should give me my answer for pressure in atmosphere, okay, which is going to be equal to 5.4 atmospheres. Okay, so Dr. Hudson, what about the fact that they have it laid out like this? Well, you can do it that way too. You can lay everything back out, and instead of putting the 8.3414 for kilopascals, you can do it and use 0.0821 for atmospheres, or you can do it like I told you. We know we have 540 kilopascals, and 1 atmosphere is equal to 101.3 kilopascals. So I can just divide this by the standard, which is 101.3 kilopascals, and that is going to get me the 1 atmosphere. It's going to get me my answer in atmospheres. Why? Because this is kilopascals per 1 atmosphere. Now be careful. Don't think that that's just going to convert it to torrs and everything else, because it doesn't convert it to torrs. If I was trying to get torrs, it'd be 101.3 per 760 torrs. That's a whole different thing. So if you're going to convert from one unit to another, you can use your standards as your conversion factor. In this case, 540 times 1 atmosphere per 101.3 kilopascals is going to give me atmospheres. But again, if I was trying to convert it into torr, then it would be 540 times 760 torrs per 101.3 kilopascals. That's a whole different way you do a number. So that's just a shorter way of doing it. Either one is perfectly fine. All right. Pause the video. Make sure you can do the problem. Make sure you can do that kind of conversion. So either way you do it, as long as you make sure that the conversion you use gives you the accurate number. So if I were you, I would do both ways until you figure out which one you want to do. And you can either do it by redoing the problem twice, or you can just do it by a simple conversion factor, using the conversion factor like we do for moles. All right? Okay. 7.7 moles of gas at a pressure of 0.09 atmospheres has a temperature of 56 degrees Celsius. What is the volume of the container that the gas is in? Okay, this looks like it's kind of been set up for you already. Yeah, it set up for you already. That was nice of them. Okay, so here is our pressure, and here are our moles. Here is our temperature, and notice that they fixed the temperature and converted it into Kelvin here. And so all they want to know is the volume. So you have your pressure and times your volume is equal to N times R times T. Because we want to know what volume is, we're going to divide both sides by the pressure. Okay, so make this a little bit easier. We're going to go ahead and just write 0.09 and divide this by 0.09. This cancels out. So you have open parentheses 7.7 times 0.0821 times 329 close parentheses divided by 0.09. Press the equal sign for your volume, and your volume for this is then going to be 2311, and it's in liters because we said volume has to be in liters for the ideal gas law. Okay. If an unknown quality of gas at a pressure of 0.5 atmospheres, a volume of 25 liters, has a temperature of 300 K, how many moles of the gas exists? Here they've laid it out for you. Once again, you have your pressure, you have your volume, we're looking for the moles, you have your R value, you have your temperature. Okay, so in order to solve this, we're going to have to divide both sides by your R value and your temperature. So we're going to divide this by 0.0821 times 300, and this is going to be divided by 0.0821 times 300. It cancels out over here, so that N is equal to, open parentheses, 0.5 times 25 close parentheses divided by, open parentheses, 0.0821 times 300 close parentheses. Press your equal sign, and your answer should be 0.5 moles. Okay, how are you feeling? If you're getting these, you're doing just fine. I would go back over this video a couple of times to make sure that you got that down pat, because the ideal gas law is a little bit more complicated. But if you're feeling good about it, that's wonderful. If we still were unable to answer the questions that you've written down about application and concepts, or if even going back and replaying this lecture video doesn't answer those questions, then please make sure that you address them with your instructor. Have a great day. Goodbye.